So if we're going to do a question like number 10, we're assuming that number 10 is a right triangle, and so we would try to use the Pythagorean theorem to find that missing side. So let's take a look at it. We've got three sides given to us. What is the unknown side? Is the unknown side the hypotenuse or one of the legs? It is, yeah, it's one of the legs. And so if we're going to set up the Pythagorean theorem, Alec, how would you set that up for this particular triangle? You said 12 squared, and I lost you on the second part. 12 squared plus? I don't see any b's up there. I would go with x. Yeah, 12 squared plus x squared. And then you said equals 13 squared. I know we get into the habit of calling everything a's, b's, and c's with the Pythagorean theorem, but let's try to keep it with what they've listed up there for us. Okay, let's simplify. Let's see if you guys can remember this. 12 squared. Anybody remember?
144.
144, that's right. And what about 13 squared? That is right. So if we're going to try to solve this for x to find the missing side, wouldn't we have to subtract 144 over from both sides? So when you do that, 169 minus 144 is 25. And this is where we could talk a little bit about the plus or minus thing that we mentioned a little bit yesterday. But for now, I would encourage you to think about it this way. At this point, you're asking yourself, what number squared is how about I write this correctly? What number squared is 25? Somebody could also accurately answer, and they could say negative 5, couldn't they?
Yeah.
Isn't negative 5 in parentheses squared 25? Yeah, so you could say plus or minus 5 here. They're like, what number squared is 25? However, we're dealing with a triangle, and having a negative side length for a triangle, as we talked about before, makes no sense. And so here I think we would just take the positive side of the square root, and we would say x is equal to positive 5, and we'd have the side lengths of the triangle. Fair enough? Okay. So you'll get a chance to practice this here in just a second. Let's take a look at number 11, which is Bob and a house. And this is the question I was referring to. So I wanted to share with you guys, as we were working on building this house, one of the things that I did a lot of early on is I built walls, right? So we had beams going across for the floor, and we put some decking on the top, and we built these walls, walls not unlike this. And you guys know that inside these walls, they're either, probably in here, they're metal. For us, they were wood. There's like 2x4s. And so if you could like strip away all the drywall that's on these walls, what you would essentially see is this. You would see, you would see what's called a top plate, and you would see some 2x4s vertically like this, and you would see a bottom plate, and then on top of that you put the drywall and the paint and all the nice looking stuff. So as you're building this wall, you don't know whether that wall really is straight. For instance, you could be building the wall, you could have your bottom plate, and you could have your 2x4s. Your 2x4s could be leaning a little bit. And when we're talking about like a large wall, like maybe the section of wall you're doing is like 10, 15, 20 feet long, it's really difficult to just look at it and be like, oh yeah, that's square. And the thing about a house or a building is, if you're building a wall, and even if that wall is like 1 or 2 inches out of being perpendicular, out of having right angles, you're going to pay for that later, right? Your walls are going to be crooked, they're going to be wavy. When you try to put on all the drywall, the drywall is going to be crooked, it's going to make that much more difficult, and things are going to start moving, you're going to get cracks in your drywall, so you want these walls to be perpendicular. Right? You want them to have right angles all over the place. And so the way that you do this, and believe it or not, I want you to think about this for a second. Stop writing. I want you to think about this for a second. This goes beyond just the can you do the math. Think about like a large building, like my parents' house, like the footprint is about 3,500 square feet, so it's a pretty big footprint. That's really tiny compared to this building, isn't it? I want you to think for a second. Like think about like all the corners in this building, especially the corners on the far edges. Those corners are supposed to be right angles, aren't they? If they aren't, the building is going to be way out of whack. Things that are supposed to be here are going to be here. It's going to be so difficult to build. So how do you think that they make sure that like that angle on this corner down here or the one over there, how do you think the construction folks know that for sure it's a right angle?
They use a right angle.
A right angle tool? Well, here's the problem though. I want you to think about this. We are talking about large scale things. right? We're talking about like walls that might be 10 feet tall. We're talking about a building that's probably 150, 200 feet long at least, maybe 300 feet long. It's a really long building, isn't it? There's no such tool that's going to stretch. I mean, think about this. Is there such a tool that's going to stretch like halfway down the building and another, like a protractor? You picture a protractor that's going to like cover half the building to make sure that you got the scale right? I mean, what kind of a truck is going to bring a protractor that's like 80 feet long? Can you imagine you're driving down the highway and there's one of those trucks with oversized load? And there's like this 80-foot long protractor. You're like, whoa! It must be like a varsity, geometry teacher needs the 80-foot protractor. There's no such tool. Do you know what they do? They do what Bob's going to do, and here's what we do. You use what's called, I'll highlight it for you, you use what's called the diagonal. The diagonal connects any two non-consecutive corners of a rectangle or a square. And so in the case of these walls that I have built up here for you, a diagonal could be drawn from there to there. Let me try that again. There to there, or there to there. Those are representations of diagonals. Do you see that when you draw a diagonal in, you've created a right triangle, hopefully? And so what we can do then is we can use the Pythagorean theorem to truly understand if that diagonal is the right length. If it is, that means we have a right triangle. And it means that our wall is square. So you want to know what they would do on a building like this to make sure the foundation actually is square? They would, in this corner down here, they would take some kind of a rope, a cable, wire of some kind, and they would stake it on this corner of the building. And then they would stretch it all the way across to that other corner of the building way over there by the, kind of by the gym. And they would measure that diagonal, and they would measure this side, and they would measure the other side, and they would do the Pythagorean theorem. Isn't that amazing? There's no tool to measure. Think about this. This is a large building, isn't it?
The hypotenuse is the diagonal.
Correct. That's right. This is a big building, but do you guys know, have you seen they're building a really tall building downtown Denver? You seen that? Like a building like that is way bigger than this, right? It's like a city block by a city block.
I think it's like taller, not like.
Taller. It might be the same dimension this way, but it's way longer this way. And it's a lot taller. So think about this. If you're off by just an inch, no, I was just thinking about how silly this would look. If you're off by an inch on a right angle down below, when we're talking about a building that's like 600 feet tall, how stupid would that look if the building is like that?
The Leaning Tower.
Leaning Tower of Denver? Yeah, that actually happened because soil settles, but yeah.
The wind blows over.
Anyway,
Pizza.
so
I've been there.
let's get rid of our ugly wall and let's take a look at this wall right here. So in this wall, wouldn't it be fair to say, guys, listen up please. Wouldn't it be fair to say that the diagonal is our hypotenuse? This would be one of the legs down here. This would be the other leg right there. Maybe you can see the right triangle. The goal being that we want that angle right there to be a right angle. Because if that's a right triangle, then that really would be a right angle, and our wall is happy. It's going straight up and down. Make sense? Okay, so let's take a look at what we got here with Bob. Bob is constructing this wall for an addition to his house. He has measured the base length to be 16 feet. So you should draw a picture here with me. In yellow, of all things, but
We have both of you.
interesting. Okay, so Bob has gone with a 16-foot long wall, and he has a height of 10. So if this wall is supposed to really be a wall with right angles in it, how long would the diagonal have to be? So what would we use? Correct. And how would we set it up? Yeah. Go ahead. X squared. Yep.
Plus, let's do 10 squared
Okay.
equals 16 squared.
What do you guys think of that for a setup?
Well,
Why not?
I don't like
because it's the a squared plus b squared
Oh,
equals c
sorry,
squared, and
so
c is the
sorry.
hypotenuse.
I messed
You want
up.
to amend something?
Yeah.
Okay, so she's going to change a little
So
bit.
do I do 10x squared, or 10 squared plus 16 squared equals x squared?
And what does x stand for in your equation?
Our hypotenuse.
Our hypotenuse, or the diagonal, right?
And then you're gonna, so like, So then do 100
Yep.
plus
256.
256
256 is right.
equals x squared
You got it. So then
56.
356, yep.
equals x squared. So 356.
So how do we get the x by itself? How do we undo the squared?
Oh, I got it. 356
Square root it.
equals x squared square root.
We do. Now again, you really could include the plus or minus with this. However, we are talking about a wall. A negative diagonal length just simply doesn't make sense. What is that 356?
18.87.
Okay, so 18.87 feet is equal to x. So really, honestly, in the interest of helping you guys understand where, when, why you would use this, it's very simple. I did this calculation over and over and over and over when putting up the wall segments in my parents' house. I would nail them all together, I'd measure the base, I'd measure the height, I'd measure the diagonal and be like, oh my gosh, I'm off by like 10 inches. Better, knock the wall over a little bit. Or, you can actually nail a diagonal on right there just to keep it to be a right angle. But you got to make some kind of adjustment, and then you raise the wall and you nail it into place and you move on to the next section. The point simply being the Pythagorean theorem was essential. Believe me, if you look at someone framing a house or putting a foundation in, they're not out there with a bunch of protractors, like lining up these little plastic protractors or even big ones, like you see in geometry classes. They're out there with a rope or a string or whatever, measuring a diagonal and calculating with the Pythagorean theorem, make sure that their diagonal is the right length for the base and the height. Okay? So a very useful thing. If you ever find yourself building something, and believe it or not, I find myself using stuff like this a lot. I do like to build things around my house, and in certain situations you want to have right angles, and so it's a very simple thing. Just use Pythagorean theorem. In some cases trigonometry, which you'll learn about later, but Pythagorean theorem is definitely a useful thing. Any questions at all? Okay, cool. Let's do a little bit more here, I think. Yeah, so this will be our last topic in 8.1. So this is called the distance formula. It involves a square root, so it fits in here pretty well. So the distance formula gives a framework or a formula for finding the shortest distance between any 2 points. The shortest distance between any 2 points. When we graph things on the rectangular coordinate system, we live on a grid, right? You got to go in the x direction, then you go in the y direction. The distance formula allows you to calculate the shortest distance, which could be a diagonal distance. For example, if I'm standing right here, let's say, and I need to go talk to Rocky, I could go talk to him in lots of ways, right? I could walk this way. This would be like walking along the x-axis, and I can get right here and I can turn and face Rocky. This would be a really dumb way to do it, couldn't I? And now I'm here to talk to Rocky. Or wouldn't this be a shorter distance instead of going like this and like this? Couldn't I just walk on the hypotenuse? You see it? This was like walking leg to leg. Now I could just walk on the hypotenuse and walk straight at Rocky and actually take a shorter distance.
That's geometry. You just move to from point A to point B is a straight line.
Hypotenuse, right? Yeah, exactly. Okay, so the formula is right here. There's a couple things going on we want to make sure we're good on, and then we'll do one example, and then we'll do some practicing. So the distance formula between 2 points, the first point being x1, comma y1. So that, another way of saying, hold on, the first point, and then the distance between that and the second point, which would be x2, y2. Those, I want to be really clear about that. Those numbers in there, the x1 and the y1, the x2 and the y2, you can see how they are lower than the x and the y. So that means that they are not exponents. They are subscripts. And all they're there for is to tell you that it's the second point or the first point. They're not exponents at all. They're just little subscript names. Okay, so the distance formula is right there. Distance equals the square root of the difference in the x's squared plus the difference in the y's squared. And you can memorize this formula, and you need to, but I want to share with you where it comes from. Is that okay?
Yes.
Well, I hope it's okay, because that's what I'm going to do.
We said no. Like, what would you do?
I would say tough, and we'd still do it. I'm just hoping that you'd be into it. Okay, here we go. Where does this come from? This comes from, in a brief description, it comes from the Pythagorean theorem. as you might have guessed. So I want to give you just a brief example of this. Bottom line here, I want to make sure that you understand where it comes from, but I want you to be able to use it. So we'll use it here in just a second. So here we go. Let's say that I've got 2 points. I'm going to put one point right here. I'm going to put the other point right there. I'm going to call this point up here, let's see here. I'm going to call this point x2, comma y2. And I'm going to call this point right here x1, comma y1. Okay. So the shortest distance between those 2 points would be this blue line right there. Isn't that fair to say? That's the shortest distance. You point straight at it and you go. Say again?
The slope.
Well, so the slope measures how steep that is. The slope does not measure how long that line segment is.
That's what I was just saying.
So it would be a sloped line in this case. I agree. Doesn't have to be, but this one it would be. So then to figure this out, what I would say, to use the Pythagorean theorem, I would draw a little right triangle here, like this. This side length over here, the vertical side length, wouldn't that be related to the y's? Isn't vertical on a graph related with y?
Yeah.
So I would say that this point up here, the second point, has a height of y2. And this location right here has a height of y1. So how do you find the distance between the y2 and the y1? How do you find the distance between two things? You subtract, yeah. So that side would be y2 minus y1. And then kind of a similar concept for this horizontal side. I'm making it purple now. That horizontal side, that's going to be, since it's horizontal, it's going to be related to x's. And so I would say that this point over here has a value of x2. The point on the left has a value of x1. So kind of like Evan's idea, to find that distance there, you would subtract. You get x2 minus x1. Now here's where the Pythagorean theorem comes into play. That's a right triangle, right? Because all those angles on the grid are right angles. And so we would say, come back over here and say leg squared plus the other leg squared is equal to, close, d for distance. It wouldn't be d.
For volume.
No, we're talking about distance, not volume. But it wouldn't equal,
Hypotenuse?
say again?
The hypotenuse?
It wouldn't equal the hypotenuse. The hypotenuse would be d, right? But it wouldn't equal the hypotenuse. It wouldn't equal d. It would equal, come on, what's the Pythagorean theorem? Leg squared plus
C squared.
d squared. Are you using d for distance? Yeah. So it wouldn't equal d. It would equal d squared. And then if our final goal is to solve for d, how would I get rid of the squared that's on the d? Square root it, right? Square roots undo squareds. So we'd square root this side, we'd square root that side, which would lead us directly to that formula. So, do you have to have that formula memorized? Yes. Hopefully you'll use it enough times as you practice that it'll just like naturally happen for you. Do what you got to do, make a flashcard, write it down 20 times, say it out loud 20 times, watch a video. There's any number of things you could do to have that memorized and memorized well. Okay, do you have any questions? Go ahead.
Well,
Go ahead, Sam.
so what is our final answer?
The distance, so we'd be finding like this formula. If you square root both sides, you get that formula. So this will allow you to find the distance between those 2 points, the shortest distance. Can we do an example and kind of show you the point of this?
Yeah, I don't really understand. Yeah.
Well, you don't understand why or where or what you would use this for.
I just don't understand what answer would be like so if this was on a quiz.
Yep.
What answer would be our final
And you're referring to specifically what we've been doing for the last 5 minutes?
Yeah.
I don't think I would ask you this. What I was doing with this is a fair question. What I was doing with this was I showed you this formula 5 minutes ago, and I said, hey guys, this is the distance formula. And I was trying to prove to you that it really is. That makes sense? In just a minute, we'll use it to find something. But what I was trying to do is say, hey, you can trust me if you want, but why don't I show you where it comes from so that you kind of know where it comes from instead of my teacher said.
Oh, okay.
That's all.
Okay.
Okay, well then let's do our example here with this.
I know how to do it.
So number 12 says find the distance between negative 2, 5 and 1, 7. So what I'm going to do with this is I'm going to call this right here, 1, 7. I'm going to call this point number 2, and I'm going to call this negative 2, 5 point number 1. And my hope would be that you would have the distance formula memorized or even be able to use the Pythagorean theorem to be able to derive that. Hopefully we'd eventually arrive at this. Distance equals, please write this down with me. This will help you as you seek to memorize this. Write down distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Believe it or not, this formula is used repeatedly in many, many math classes, including calculus, trigonometry, etc., etc. This is a very useful formula. Say again? Must be mom. Okay, so here we go. So if point number 2 is 1, 7, what's x2?
Can you repeat that?
If I've labeled 1, 7, point number 2, what would the x2 in our little formula have to be?
1.
It would have to be a 1, right? Because 1 is the x-coordinate within that point. So I'd go distance equals square root 1 minus, well, if 1 is x2, what's x1?
Negative 2.
Negative 2. So you're right, it'd be 1 minus negative 2. That'll end up being plus.
So it's 9.
So we'll square that, eventually we'll get 9. You're right. Plus, this will all build on itself. So if x2 was 1, what's y2? What does that have to be? 7. Yeah, you're right. So 7 minus, what would y1 have to be? 5. You're right. Good. And that would be squared. Now we just do a little arithmetic. Rocky did some of it for us. This would end up being 1 plus 2, which is 3. 7 minus 5, of course, is 2. Keep going with order of operations here. 3 squared is 9. 2 squared is 4. That would give us the square root of 13. Just for fun, use your calculators. Let's approximate this to the nearest hundredth. Square root of 13.
It says the 10th, though.
Oh, it does?
Yeah.
Let's do 10th. Sorry, I didn't read my own instructions. What is it?
3.6.
3.6. I'll put approximately equals 3.6. So using the distance formula, once you know it, once you know where it comes from, it really is, at this point, kind of a plug and chug sort of a scenario. Hope that works for you. Do you guys have any questions before we try to practice this a little bit?
The answer for that kind of sounds like a phone number.
Say again?
It's the number is 360-555-1266.
Oh, the 555 from the movies, yeah. Okay, so let's head to the board. We'll do some practicing with this.